Happy Monday. Hope you guys all had a good weekend. Today we're going to do section 5.2 and it's the second day of it because on Friday we factored. We talked about relative mins and maxes, and we also wrote polynomials in both factored form and standard form given the roots. So today we're going to look at multiplicity and decide what that means. So once again, I'm going to have you guys pause multiple times throughout this and try things out. Make sure you plug things into the calculator so that what you're getting in your calculator matches up with what we're doing in the notes. So first thing I'd like you guys to do is the warm up, get your brains going after the weekend. So pause me and check back to see if your answers are correct. Alright, so check to see how you did, and you might need to pause me and read through some of my notes. I decided not to put this in standard form yet. I thought we would do that together. So FOIL the first two, and then you need to multiply it by the last one. So now multiply all three of these by x, and then we'll multiply all three of these original ones again by -3. After you do that, you get these 6 terms, and now we'll just combine our like terms. After combining your like terms, you get this polynomial in standard form. Okay, so on to the new stuff for today. Okay, today we're going to be talking about multiplicity of zeros. So for every 0 or x-intercept of a polynomial has a multiplicity. The multiplicity is the degree of that factor. For example, if one of the factors is x minus 3 to the 4th, this 4 would be the multiplicity. The multiplicity of the factor tells us how the function will behave at 0. If the multiplicity is even, the function will touch the x-axis. If the multiplicity is odd, meaning like if you had something like x minus 3 to the 5th, because this is an odd number, then it will cross the x-axis. So what I would like for you guys to do is I would like you to go through and explore this. So you're going to plug both of these functions into the calculator. Make sure you use the window that I gave you so that you can actually see the zeros. And then write down what the x-intercepts are. Write down the multiplicity, if it's odd or even, and then if it crosses or touches. So go ahead, try that out, and we'll go through that after you press pause and try it on your own. Okay, so for the first one, you get a graph that looks like this. So our first x-intercept is -5, because remember we solve each factor for 0. The multiplicity is 1, because that's the exponent attached, and 1 is an odd number, so given the rule above, that means that it will cross the x-axis. And if you look at -5, notice that it is indeed crossing through the x-axis. The second x-intercept is 2. This multiplicity is also 2 because that's the exponent attached. That's even, and since it's even, that would mean that it would touch the x-axis. And notice here it's just coming down and just bouncing off, or in other words, touching the x-axis. So this one touches, and then this one crosses. So here, once again, make sure that you change your window to the one that I gave you, and you should get a crazy looking graph like we have right here. So your first x-intercept is going to be 0. And that comes from setting 2x cubed equal to 0. So that would correspond with the intersection of the x and y axis. His multiplicity is 3 because that's the exponent attached to x. That's odd, and that one is crossing. The next one is going to be -1. That has a multiplicity of 5, which is also odd, which is also crossing. And the last one would be +1. That has a multiplicity of 4. Since it's even, that would mean that it is touching, and notice that it is because it just comes down and bounces off the x-axis. Now without graphing, we should be able to do these. So go ahead, try these on your own, pause me, and then check back to see how you did. Okay, so number 3, we have an x out front, so that counts as a factor. So x equals 0, and we just get 0. That has an exponent of 1, so the multiplicity is odd, so that would tell us that it would cross. The next one comes from the second factor. That would have an x-intercept at 1. It has a multiplicity of 2, so that one would touch because it's even. And then the last one has an x-intercept of -4. That has a multiplicity of 5, and because that is odd, that will also cross. Now number 4 is a little bit different because it's not in factored form. So in order to get a multiplicity, it has to be in factored form. So we're going to need to go through and factor this one. So first thing we're going to do is, of course, look for GCF. We take out an x squared. We're left with x squared minus 8x plus 16. Now we're going to go ahead and factor that. What multiplies to 16 and adds to negative 8? Well, that's negative 4 and negative 4. So we would get x minus 4, or x minus 4 squared. So here we actually only have two zeros of 0, which has a multiplicity of 2, so it touches, and then 4, which also has a multiplicity of 2, so that also touches. And of course, you can check these on your calculator to see that that is indeed true. So now that we've explored a little bit about what the multiplicity means and how the graph behaves, let's go ahead and graph a couple. So this first one's in factored form for us, which is nice. So we want to figure out a few things. We want to think about the end behavior, we want to think about the y-intercept, the multiplicity, and then we'll just sketch the graph based off of it. It doesn't have to be perfect, we just want to get the main characteristics of the polynomial. So the degree here, without actually multiplying it all out, I know that if I were to, I would have to at some point multiply x times x times x. So I would get an x cubed. There's no negative out front, and there's no coefficients. So I know that my leading coefficient will have to be an x cubed, which means that my degree is 3. Remember, degree is just the biggest exponent, so I don't really care what the rest of it is. The zeros come from our factors. The first factor gives us an x-intercept of negative 1. They all have an exponent of 1. We can't see them, but since they don't have an exponent, that does mean 1. So since they all have an exponent of 1, they all have a multiplicity of 1, which means they will all cross. The second x-intercept is 2, and the last one is negative 4. So we can go ahead and we can actually plot those on the graph. So negative 1, 2, and negative 4. Remember now to find the y-intercept, we plug in 0 for x. So if I plug in 0 for x, I'm going to get 0 plus 1, 0 minus 2, and 0 plus 4. So that's 1 times negative 2 times 4, which is negative 8. So my y-intercept is at negative 8, so we can plot that point as well. Last but not least, the end behavior. So this is going to be down and up, and that's because of the x cubed. It's positive and odd. And now we will just sketch the graph. So down means it'll be ending down on this side, and it'll be ending up on this side. I'm going to cross through each of the x-intercepts, and then I need to make sure that I go through the y-intercept. So cross, it's going to have to come back down to cross through the second x-intercept. It's got to go through my y-intercept, and then cross my third x-intercept. Now this isn't a perfect sketch. Of course, we could go through and find the relative min and the relative max on our calculator, but for now, I want to mainly focus on the multiplicity and sketching the main characteristics of the function. I would like for you guys to try out number 6 on your own. Pause me, and then once you've gotten as far as you can, start, and I will go through and explain the problem. Okay, so number 6 has a degree of 4. Once again, without actually foiling it out, if I were to foil this, I were to get an x squared. If I were to foil that, I would get another x squared, which means that once I'd foil, the biggest thing I could possibly get would be an x to the 4th. Once again, it's a single x and a single x, so that's why I know my coefficient out front is 1. So the degree of my polynomial here is 4. The zeros are negative 3 and 2. That comes from my two factors. Both have a multiplicity of 2, which means it will touch at both of those points. So we will plot our negative 3, and we will plot our 2. Now we need our y-intercept, so we will plug in 0 for x. So we get 9 times 4, which is 36. So that number is huge here. So I'll just go by 4s. So this point right here is 0, 36. Our end behavior is going to be up and up because it's an x to the 4th. This is even and positive. So we know it's going to be up and up on the two ends of the graph. So since we know we're going to touch, we're going to come down to this x-intercept. We're going to bounce off, touch, go through our y-intercept, touch our other one, and go back up. So all we need there, once again, is just a sketch. right, last but not least, today we have a couple word problems. So using a polynomial function, we're going to maximize volume. Number 7 says the side of a cube measures 2x plus 1 units long. Express the volume of the cube of the polynomial. So all we're doing is, here we're just going to actually write the volume. So a cube has a side of 2x plus 1. If it's a cube, I know all of these sides must be the same. So that means that the length, the width, and the height all have to be 2x plus 1. So volume is length times width times height. So I can just write the volume as 2x plus 1 cubed. And once again, since this just says express the volume, we're not going to maximize until number 8. Okay, so I'm going to erase some of this so that we have a little bit more room for number 8. So number 8, now we're actually going to go through and maximize. So a rectangular box has a square base. The combined length of a side of the square base and a height is 20. Let x be the length of the side of the base of the box. So if this is the base of the box, it says let x be one side, so that means that this guy also has to be x. The other thing that it tells us is the combined length of a side of the square base and the height is 20. So that means that this and this together have to make 20. So we'll call this one 20 minus x, because now when we combine the two and add them, we just get 20. So we know that that will make the total. So now we're going to go ahead and write the volume. Length times width times height. So instead we can just write this as x squared and then 20 minus x. So now it says what is the maximum possible volume of the box. So let's go ahead and graph this function and then we're going to look for the maximum. So pause me, plug it into your y equals, and let's take a look at the max. Okay, so first of all, we had a funny window from before. So if you press zoom 6, then you get another funny looking graph that just kind of looks like this. Which makes sense because here you can actually see the x-intercept at 0. And we know that we have an x-intercept at 0 with a multiplicity of 2, so that makes sense that it's just coming down and touching. But our other x-intercept is all the way at 20. So we know that this is going to have to come up and then it's going to have to come back down at 20. So we know it's going to look something like this. We just want the actual maximum. So we're looking for this point right here. So we need to figure out how we're going to do that. So what I would recommend is finding a good window. So that means that we're actually going to have to change our y max. Now we can do that by looking at the table and just guessing, using that to help us make our guesses, or you can just start guessing. So let's see what happens if we change, let's say, our window to 1,000. Remember, if you go bigger, it's okay. You can always adjust it. We're only looking to see that point. So if we make a huge window, it's no big deal. So let's change our y max to 1,000. And we also have to change our x max to, let's say, 25. Because remember that it has to include 20 because we know that that's our other 0. Now with it at 1,000, we once again cannot see the actual maximum, so we're going to need to make it even bigger. So how about 1,500? And then we should for sure see it. And at that point, you do see the maximum. So here, you'll want your y max to be 1,500. There's lots of different things to pick. Your y min can stay at -10. And your x max should be like at 25. I know that these are kind of out of order, but at least that'll help you with your window. And now you're just looking for that point, so you're going to go to second calc, and you're going to find that point. So make sure that you can pause me and actually find a good window for that polynomial. When you do second calc and you find the maximum, this is the maximum that you get. Now remember, once again, we're trying to find the volume, and in this case, the volume is our y value, and the x, remember, that's just the side length of the actual box. So the max volume here is 1185.2, and this is in inches, so the volume would be 1185.2 inches cubed. Your homework is a worksheet, so you can work on that for the rest of class. Have a good afternoon and go back and review some of these notes if you still have questions. And of course, you can come see me in the morning if you have any questions as well.